All right, our last video on elimination. So what happens if we have three variables or a system of three equations? So here we have x, y, and z. Sometimes my z's look like 2's, so I'm going to put a line through my z's to make it seem hopefully clear which is which. Now, same thing with elimination with two systems, or a system of two equations, is we're just trying to figure out what is going to be the easiest thing for me to get rid of. So what I see initially is that I have a positive y and a negative y. So if I take lines 1 and 3 and I combine those, I can eliminate the y's right away without doing any work. So what I'm going to do is I'm going to rewrite line 1. So I'm just going to rewrite line 1 down here. So that's 3x plus y plus z equals 5. And then I'm going to rewrite line 3. Line 3, I have 2x minus y plus z equals positive 2. Now, why am I doing that? I just think it makes it easier to rewrite it so that we can keep the original lines as fresh as possible. So what's going to happen here is the y's cancel out. I have a positive 1 and a negative 1. That gives me 0. 3x plus 2x is going to give me a 5x. That's a 5. A 1z plus another z gives me 2 of those z's. And then 5 plus 2 gives me 7. So 5x, y's are gone, 2z, and 7. So this isn't too bad. Once you get rid of one variable, though, you're going to relabel this as line 4. So this is going to be line 4, and we're going to use this later in the problem. So I'm actually going to rewrite line 4 over here, because I'm going to save this for later. So 5x plus 2z equals 7. I know, we're going to have 5 lines total. Now, because I used lines 1 and 3, and I got rid of y, that means my goal now as I'm looking at this problem is to get rid of y again. But either, I can't use lines 1 and 3 again. I have to use either lines 1 and 2 or lines 2 and 3. So I can't use the same two lines. So what would be easiest? Probably 2 and 3. See how I have a positive 2y here and a negative 1y? Well, for those to cancel out, if this is a positive 2, I need this to be a negative 2. So how do I make this a negative 2? Well, one way is to multiply line 3 by a negative 2. And that would get what we need. So I'm going to rewrite line 2, because line 2 is the one I'm not changing because it's already a positive 2. So I'm going to have x plus 2y minus 3z equals 15. Now, number 3 is going to be my new line 3. So this is my new line 3, meaning after I take line 3 and I multiply or manipulate it by multiplying by negative 2, it's going to get me what I want, meaning if this is a positive 2y, I need a negative 2y, so those cancel out. Oh, I'm sorry, I'm not multiplying by a negative. I'm going to multiply by a positive 2, forgive me. So after I multiply line 3, yeah, there's some of you, I hear you at home going, see, I knew you were wrong, and you were right. I'm proud of you. So positive 2y, I need that to be a negative 2y. Therefore, I'm going to multiply by 2 to make it a negative 2. Okay, so my new line 3, after I multiply by 2, 2x times 2 gives me 4x. Negative y times 2 gives me a negative 2y, which means those will cancel out. That was our goal. Positive 1z times 2 gives me a positive 2z. And then finally, this is going to equal 2 times 2, which is 4. Okay, so now here's lines 2 and 3. My y's cancel out just like I hoped. X plus 4x is 5x. A negative 3z plus a 2z is a negative 1z. And then 15 plus 4 is equal to 19. Okay, so this is actually line 5. We have two lines now, lines 4 and 5, where the y variable is eliminated. So I'm going to rewrite line 5 over here just so we can see it all in one spot. And I have 5x minus a z equals 19. So we're almost done, kind of. This is now just like systems of two equations. This is a positive 5x and another positive 5x. So one thing that you could do is you can multiply this by a -1, and that can help you out a lot. So let's go ahead and do that. It doesn't matter if you multiply line 4 or 5 by a -1. Let's go ahead and I'm just going to multiply 5 by -1. I'm going to multiply this line 5 by a -1, and I'm going to rewrite my line 4. So just to stay organized, keep the original lines clean, I want to rewrite line 4, so 5x plus 2z equals 7. Now my new line 5, after I multiply by a -1, what I'm going to get is -1 times 5x gives me a -5x. And again, our goal was to get rid of that. So we reached our goal. -1 times a -z, be careful there because that's a positive 1z. And when I add those down, I get a positive 3z. And then equals 19 times -1, so this is going to be a -19. And 7 minus that 19 gives me a -12. So line 4 I didn't change. I had a positive 5. I was just going to leave it. Didn't matter which one you picked. Line 5, I saw that, hey, if this is a positive 5x, I want that to be a -5x. The only way to make that a -5x is by multiplying by -1. That got that to cancel out. After I combine the other two columns, we have 3z equals -12. Now to finally get a solution of at least one variable, you divide by 3 and we get that z equals a -4. Now it's 3 variables though, so we're actually looking for an x, comma, y, comma, z. So we only have 1/3 of the work done. But actually it's not really that bad. Finding the other two solutions isn't that hard. Let's look at our original lines 4 and 5. We have them written down here as well, lines 4 and 5. Now that we know what z equals, z is -4, let's figure out what x equals. Let's just find the easiest ones. Let's just use line 5. So from line 5, I'm going to replace everywhere I have a z with a -4. So line 5, I have 5x minus z. Well, z is -4, so minus a -4. Why would I choose to do that? Because I want you to remember that we have minus a negative, that makes a positive. So really, what we're saying is we have 5x plus 4 equals 19, which that doesn't make it that challenging. Now, to get x by itself, I'm going to subtract 4 from both sides. So subtract 4, and I get 5x equals 15. Finally, after dividing both sides by 5, I get that x equals 3. So now we have x, comma, we're missing the y, comma, z. So 3, comma, something, comma, -4. Let's figure out what our final variable is going to be. Let's figure out what y equals. In order to do that, we have to go all the way back to the beginning, which is why I wanted to keep these as clean as possible. I didn't want to cross things out. Let's just pick one that looks like it has the smallest numbers. Looks like line 1 has pretty small numbers. Line 3 also has small numbers. It doesn't matter. It's just, if you can make it easier, then great. All right, line 1. Let's choose line 1. So what I'm going to do is, over here, I'm going to rewrite line 1. So 3x plus y plus z equals 5. So 3x plus y plus z equals 5. Now, I want to substitute or replace everywhere I have an x with a 3 and everywhere I have a z with a -4. So let's see what that looks like. I'm going to replace everywhere I have an x with a 3, so 3 times 3 plus y. Now plus z, I'm going to replace everywhere I have a z with a -4. So this z just becomes -4 equals 5. Let's distribute or combine any like terms that we have. 3 times 3 is 9, so we get 9 plus y minus 4 equals 5. We have like terms here. We have a positive 9 and a -4. When I combine a positive 9 and a -4 together, I get a positive 5. So I get 5 plus the y left over equals 5. How do I get y by itself? I'm going to subtract 5 from both sides. When I do that, I get that y equals 0. Remember, 0 is a number. So my final coordinate point is going to be x comma y comma z. And so in this case, my x is 3, comma y, which is 0, comma z, which is -4. And so this is going to be my solution.